Now what we need is the next step what we want to do is we want to update our points. So as we had these points, okay, so now let's suppose right now all of these points are assigned to them and all of these points are assigned to this, but we can see that okay, this point is to this part. So what we want to do is we are going to update our center. So how we are going to update them? We are going to take a mean of all these points and we are going to change the value there. So if we will take a look at like this, so we can have a center like this, and if when we are going to update this, what we are going to do, we can have a center like, because all of the majority of part is here. Now when this part is done, what we are going to do, when this part is done, what we are going to do, we are again going to find the distance and again going to repeat the steps. So this time it might could come under this part. Okay, so this is how it is going to do, and it is not necessary that this technique is always going to work, and you will see what I am talking about. But this is a pretty good method to find out without using the output. Okay, so we are going to make that def update clusters. This I'm going to give the clusters. Okay, and for kx in range of k, so for every point, what we are going to do, we are going to get all the points. So np dot array clusters kx points. So we are going to get all the points, convert them to array. Okay, all the points that is associated with the current cluster or with the current center. Now if pts dot shape shape 0 is greater than 0, it means if we have any point, then we are going to do this. If we do not have any point, then we are not going to do this. So new underscore q equal to pts dot mean axis equal to 0. So what we are doing here is we are just finding the mean of them, mean of the points that we have. And why we are using axis 0? Because we will have points like this, x0 x1. So we will have some x0 x1, this will be one example, x0 x, this will be another example. So we are finding the mean on the basis of the columns. Okay, so this is how what we are going to get. Now we will have the new mean, and what I'm going to do is clusters kx. So our new center is going to be new underscore q and clusters kx. As we have to repeat all these steps again, so what I'm going to do is I'm going to set the points as empty. So we do not have any new point right now. Okay, we set the points as new because we have now a new center and we are going to find out the distance on the basis of this center. So this is what we are going to do this in this part. And let me make the last function that is going to plot the cluster. So def plot clusters. So now we want to plot all the clusters. So what I'm going to do is for kx in range k, for all the centers, what we are going to do is we are going to get the points. So np dot array, let me just copy this line. Okay, and what I'm going to do is try plt dot scatter PDS points, and in this I'm going to get all the points from the 0th column and all the points from the first column. And why we are doing this? Because as we have done here, this is the same part. Okay, so this is going to be our scatter and accept pass. And why we are using try and accept here, and the reason is that we may not have any point to scatter. Okay, and you will see that why it is that we do not have any point. You will see when I will run the example. Okay, so now what I'm going to do is uk is equal to cluster kx center and plt dot scatter. So this is nothing but our new center, or our center. So uk 0 and uk equal to 1 and color equal to black. Also we want to separate our center from all other points, so marker is going to be asterisk. Okay, so this is going to be our thing here, and what I want to do here is I think that it is complete now. Let's run this. Okay, we do not have any error now. Let's call assign points to cluster, and in this I'm going to pass the clusters. Then let's make float clusters. Again in this I'm going to pass the clusters and update clusters. So clusters. So what it is going to do right now, we have a cluster in which we only have initialized 5 random marker or 5 random centers. Okay, now what we are going to do is we are going to assign the points to all these clusters. Okay, I hope that it is clear that what we are going to do is we are going to assign the points to these 5 centers. Then we are going to plot them, and then we are going to update the centers or update the cluster. So let's see what it is going to do. So it is saying clusters, I guess. Yeah, this spelling is wrong. Okay, so float cluster key errors loop. So it should be UKS from. Okay, it is still telling that this is wrong. Let me see what the problem is. Okay, so this should be clusters, not cluster. So as you can see here, what we have is we still have one error. Update clusters. Okay, so let's see here what we have these 5 centers randomly initialized. Okay, and what we have here is you can see that how many clusters we got. So we have this cluster, the orange cluster, the green cluster, the blue cluster, and the red cluster. As you can see that we do not have any 5 clusters. That's the reason that I told you that it might be that sometimes what happens that no point get attached to some points. So let's suppose what I'm saying here is, as this is the farthest point, so what could happen is that, okay, let's suppose this point is assigned with this. Okay, and let's suppose this point is assigned with this. Okay, this point let's suppose is assigned with this, and this point is assigned with this. Because this point was the farthest, so no points were assigned to this. That's why I used this try and pass, because there might be a possibility that there is no point assigned to this, and this is the main drawback of k-means, that there is a possibility that no point is assigned to you. So what you can do is try to run this again, and this time also we have only 4 points. Now run this again. This time also we have 4, again 4, and oh sorry, yeah. So what I am doing here is this was my fault. So as you can see here, now this point has not moved but all other points have moved. So let me run this again. Okay, so we have, this time we only have 3 classes. Okay, so we have to run this again, and 1 2 3 1 2 3 4 5. So right now, because because of the random initialization, what happened this time is we have 5 classes. So what 5 classes we have? We have this class, we have this class, we have this class, we have this class, and we have this class. So this is all depends upon the random initialization, that where our random initialization is going to occur. And this problem is I will make another video to explain how we can overcome this problem, but for right now. But as you can see here, what has happened is that we have assigned the points to the cluster, then we have plotted the clusters, and then we have updated them. Okay, so if I will again call them, so you will see that the points position will change. So as you can see here, let me zoom out a little bit. I hope that it is clear now. You can see that this point that was here has now moved somewhere here. This point which was outside of all of these points have moved inside. Now this point which was here is now here, and red has not moved too much. So now let's call these functions again, and we have to call these functions again. You can use a loop to call them, and you can call these functions again and again until these points do not move at all. So if I'll call them, now you can see that it has moved again. Okay, let's call them again, and this time, yes, some points, the clusters have, the centers have moved again, and I don't think that it is going to move again. So let's run this one more time. Yeah, the output is similar to the previous one. So the centers have not moved and they are not going to move. So now as you can see, without the use of y, or without the use of any output, we were able to classify them like this. We were able to classify them like this. So this is the benefit of k-means, that you can do this very well. And in the next video I am going to show you a technique in which you do not have to do the random initialization, so that you will get every time you will assign a point to some point. Okay, so this is what I'm going to do in the next time. So thanks for watching, and I'll see you next time.